Hello guys. Today I'll explain experiment 3, which is on full bridge rectifier. Let's start. Then here we have our aim. You can read through the aim yourself, but in simple terms, they want us to design a full bridge rectifier that gives you 12-volt output with a DC. That's 12-volt output DC. Then maximum load current 0.2 amps DC. Then your ripple voltage should not be greater than 2 volts. Then as you can see, here is some formula of your design. They already gave you uh, the calculations that they already gave to do your calculations and everything. You can check through this. Then the components we need is you have your diodes, your capacitor, and your 27 ohm 10 watt resistors. 4 of them in this case. Then you get your supply. But in our labs, I don't think so. We have 10 to 10. Most of the time, we have 19. Most of them, they give you 19 volts RMS. Then some might give you 11 volts RMS, and some might give you 16 volts RMS. So depending on your, and this is your V secondary. Just remember that. That's your V secondary voltage. This one there. Depending on your V secondary voltage, your output voltage, this DC voltage will change. So some of you might not get 12 volts. So you're required to do your calculations and everything to see how much RMS voltage you are getting. Then according to this, what is your expected, what do you call DC output? In this case, they do the calculation. They get around about 25, but 25.9 volts DC. Depending on yours, how much will you get? So you can do the calculation and see. Yeah, then let's go to. Then as you can see, this is our circuit diagram here they gave us. You can also check that. Then let's start with procedures. Or yeah, the pros or the instruction to follow when you're doing the experiment. So the first instruction says you connect your bridge rectifier with the, what you call, with your AC supply. So for me, I did it on a software. It's online software. You can go and find it. It's called Tinkercad. It has the breadboards and everything. So as you can see, this is how I have connected my diodes. And I said this is where I supply my positive AC voltage, which is your red wire. Then this is where I supply negative AC, which is your black wire on your AC supply. Yeah, and then I would recommend you connect your bridge rectifier, something like this. It's easier to work with. Then also remember, just I would recommend you have this big space on your breadboard. So just to connect this side with this side, just take a small jumper wire and connect for all 4 of them. That makes it easier for you to work with. Yeah, so that's my connection for number 1. Number 2 says you switch on your AC supply, then you observe on DSO, which is your oscilloscope. You observe your sine graph of the secondary. So how do we connect that? So what you do is you take a black probe of your oscilloscope, you connect it there at the negative part of your AC supply. Then you take the positive probe of your oscilloscope and you connect it to the positive of the AC supply. When you measure on the oscilloscope, it will give you a sine wave that you will draw, which is graph, and you will draw it on the given graph paper. You can divide it into 4 parts. Then you have your sine wave, then you do your label. Here you have your V max. Somewhere here you will have your RMS voltage or something like that. Then you got your time there, or that's your period, and this is your, so this is your graph A. That's number 2. So you get your positive peak, negative peak. So this is your positive peak, this is your negative peak. Then we come to number 3, where they say move your probes across the bridge rectifier. So for that, you disconnect your probes from here, your black probe and your red probe of your oscilloscope. You take your black probe and you connect it to ground straight there. That is connected to ground, then you don't remove it, then you only move your red probe. So first you measure your half wave rectifier there. So if you measure your wave there, it should look like something like this. You have your half, then skewed half, and something like that. That's your half wave rectifier. If you measure something like this, then again you can remove your red probe, and if you connect it even this side, it will give you the same graph, or almost a similar graph, a half wave rectifier. Then to get your full wave rectifier, you connect your oscilloscope probes there, which gives you a full wave rectifier graph. So it should look like something like this. You have 2 systems, something like this. Then this is your peak voltage, or you can say Vm. That's your time t. As they say, you move, then you draw it on the graph B. So this will be your B. Then we come here, they say number 4. Connect a filter capacitor to your circuit. So you could just get a filter capacitor, and remember it's polarized. And, and remember this silver line is your negative on the capacitor. So that will go to your negative on your circuit, because it's a polarized. So polarized means it has holes, negative and positive. And just remember, here I'm just using a wire to connect there, because on the software the capacitor is not that big. But in reality you can connect your capacitor across these 2 sides. Then just take a jump and connect them in the positive and the negative. Then when you connect, then you observe the waveform across the capacitor. Now we are still number 4, so just take this positive probe, you connect it here across the capacitor, or you can just say here, it's the same point, and you check your wave, you observe your wave It won't give you anything because the load is not connected or a resistor. So that's going to be your graph AC, which you will put this side at number 4. Then they say you connect your load resistor. Now on our graph we look for our resistor. So in this case, as the software only has the quota watts, so I'm using these small ones. But for you, you will use the big watt resistors, the power resistors. So just connect 27 on there, red, and then you connect 27 on there. Then that will be your 27 ohm resistor. Again, this is just for simulate. I'm using this. In reality, you'll use the power resistor, not these ones. Then if you go there, I'm at number 5. Then they say you observe the waveform on the, again your DSO is your oscilloscope. Then you draw your graph T, where you measure your ripple voltage and everything. So your graph D will be here, and you will measure across. Then you take your red probe and you just connect here across the resistor. Then you will measure your graph there for number 5. I think so, I believe you, yeah. Then we are at number 6. They say we use our digital multimeter to measure V secondary and V DC, and we record these two values here. So your V secondary is going to be your RMS value. So let's get our voltmeter there. Now we have our multimeter here. In this case, as you can see, it's in voltage mode. So what they say is that then you can remove the probes for the oscilloscopes now. Then they say you measure V secondary. Then to measure V secondary, you just take your negative, you connect it there, and your positive. Let's say your positive, you take it and you connect it this side on the positive of the AC, then your negative will be connected there at the negative of the AC. Then you will measure your AC voltage, and remember your uh, multimeter setting should be AC voltage when you measure AC. So that's your V secondary. Then to measure your DC voltage, remember again, then you change your settings of the multimeter to be you measuring DC voltage. Then you take these two probes, you take your multimeter, you bring it this side. Here will be a positive, then your negative will be this side across the resistor between these 2 points. So that will be your DC voltage output. That is number 6. Yeah. Then number 7 says you measure your ripple voltage. To measure your ripple voltage, you can remove your multimeter. We use the oscilloscope again. The negative goes across the resistor there. Then even positive goes across the resistor here. Then on your um, oscilloscope, you change it to your DC coupling. So your DC coupling settings will measure your VM. You write that down here. So and then that's number 7. So on your oscilloscope, you change that DC coupling, and that's your peak ripple, peak voltage. You can remove this. That should be peak voltage. You can say that, or the maximum voltage. Then when you come to number 8, that's your ripple voltage. Then on your oscilloscope, you will change the setting to AC coupling. That will give you your ripple voltage here. Then you record these values in your table. Then you don't have to use this number 9. You can cancel that out. Repeat the experiment for that. Or for our case, we only used 1, so you can cancel out number 9 on your experiment. Then we come to number 10, the regulation, uh, no, load regulation. So that's table 2. So this is the number 10. So this is table 2 here. So your no load voltage, when they say here your no load voltage, so how will you measure your no load voltage? It will be like this. You can remove that. You just remove your resistor. You remove your resistor, then you can use your oscilloscope or your multimeter. Then you just measure Vm across the capacitor without any resistor. This is your no load voltage Vm. So all of them are going to be the same. This voltage, all of them will be the same no load voltage without a resistor. Then you measure your current and your voltage using your multimeter. So to measure, so in this case I don't think we need our oscilloscope. So then we have our multimeter here. Then to measure voltage, you just connect that there. A negative goes there. That's your voltage. And to measure your current, you just break the circuit there. Then you take your positive, you connect that there. Then you take your negative, you connect it there. And this is how you will measure your current. And then you record those two values in your table 2 for 27 ohms. Then they say we need to get 54 ohms. So you can just take the resistor, connect something like this. I'll just copy. Then I'll connect another resistor there. So 27 plus 27 equals 54. Then you repeat the same process. You supply that, then you measure your voltage across these two, negative and positive. Yeah, then you again, when you're done with that, then you delete that part. You remove your positive. That's your voltage. Now to measure current, just take your negative and you move it this side. That's your current. Then you do the same for it. It's 81 ohms. 81 ohms will be what? 3 times 27. Then you will have another 27 ohm resistor that's in series, which gives you 81. When you do your recording, then again 108, you just take another one, 4 of them, that's your 108. Take, then you just connect your positive there. Then you can take your positive from there, then you connect it there. That's connected there. Now you're measuring your voltage. Then to measure your current, again you break this. Then you just take your negative probe of the multimeter, connect it there, and now you measure your current. Then you can then you record these values in your table here. Yeah, then you do your calculations. Then even for percentage error, what is it? The formula here is your VDC measured minus VDC expected. So I'll say VDC measured minus VDC expected divided by VDC measured multiplied by 100. That's your formula for that. So this is this value, and then this is this value there. And even here it's going to be this value. And that's all. Then you are done with the experiment. Then remember, you have to write a conclusion there, what you learned and things like that. Yeah, I think so. That's all. And another again reminder that this is I'm just using for simulation. But for you, there are 4 white power resistors, not these ones. Yeah. That's all. Thanks, guys.